Hello students, my name is Professor Komal Birare. Today I am going to teach you the concept that is a Muri machine. Before that we will see that what is the finite automata, how it can be divided into the different form. The finite automata is divided into the finite automata with output and finite automata without output. In finite automata with output, the Muri machine and Mealy machine are present, and in finite automata without output, deterministic finite automata, non-deterministic finite automata, and epsilon NFA are present. The finite automata is that kind of a machine which consists of the different states, and with the help of transition function we can transfer from one state to another state. Now we'll see that what is meant by the Muri machine. The Muri machine is the machine. The value of output function is depend upon the present state. In Muri machine, the value of output function is depend upon the present state only. The Muri machine is divided into the 6 tuple notations. These 6 tuple notation are this. Q is the finite set of state, summation is the set of input alphabets, capital delta is the set of output alphabets, Q0 is the initial state, delta is the transition function, and lambda is the output function. Now with the help of this finite automata we will see that what are these 6 tuple notation. Capital Q is the number of a state. So here Q0, Q1 and Q2, these 3 states are used. Next, summation. Summation is the input alphabets. Here 0 and 1, these are the 2 input alphabets are used. Delta is the transition function. The transition function is always known as the next state. So after multiplication of these two terms we will get that Q0, Q1, Q2 into 0, 1. Q0, 0, Q0, 1, Q1, 0, Q1, 1, Q2, 0 and Q2, 1. If I am doing the transition of Q1 on a 0, that is when Q1 is accepting the 0, it will goes toward the Q2. So for this the next state will be the Q2. And when Q1 is accepting the 1, it will goes toward the Q0. For this the next state will be the Q0. So Q0, Q1, Q2 are the next state. Next is the capital delta. Capital delta is known as the output function. In this diagram there are A, B, that is 2 output function are used, small a and small b. Next is the lambda. Lambda is also known as the output function. So in Muri machine the output function is always come with the current state. So here A, B, B. So for Q0 output function is A, for Q1 output function is B, and for Q2 output function is B. Now we will see that what is the transaction table of a Muri machine. In Muri machine transaction table there are 2 columns are present, that is the current state as well as the next state. Current state consists of a Q0, Q1, Q2. Next state consists of the for transaction 0 and 1. When Q0 accepting the 0, it will goes toward the Q1. When Q0 accepting the 1, it will goes toward the Q1. When Q1 accepting the 0, it will goes toward the Q2, and when Q1 accepting the 1, it will goes toward the Q0. When Q2 accepting the 0, it will goes toward the Q1, and when Q2 accepting the 1, it will goes toward the Q1. So this is the transaction table. The input string, when we passing the input string of n, the output will always generated, that is n plus 1. So if I am passing the input string 0, 0, 1, what is the output string? So in Muri machine the default state will be started from Q0. So this is the default function. For 0 transaction it will goes toward the Q0 with output A, that is with output A. Next, for next 0 also it form the self loop with output A. Next 1, when it accepting the 1, it will goes toward the Q1 with output B, So A, B, these are the output string for this input string. So in this way we have studied that what is the Muri machine, what are the 6 tuple notations, next what is the transaction table of a Muri machine, and what kind of questions come in an exam. I hope students you all are understand the concept of the Muri machine. Okay, now we will see the next lecture. We will meet in next lecture with next topic. Thank you.